presentation.
Hi, welcome to this session about CDR test cases and how to create a good set of ways to test the technology. Greg, over to you.
Thank you, Dennis. Just have a few technical glitches here at the moment. Which I didn't need to do.
Just a little comment that it's worth seeing this now or recording. Going back to some of the sessions we had early last week and this week on the ISGs, which is the inspection sanitization guidance provided by the NSA, which are a great set of documents. And also we had a really good session this morning about the CDR and collaborating on this space. And I think you also have a great session yesterday on PDF fonts and redaction. So what we're trying to do here is just, kickstart this community, kickstart these discussions, and really share the knowledge and work together on some common challenges.
Okay, sorry guys, I'd like to be hopefully you see my screen. I was hoping to share in presentation mode, but having a few glitches with that. So hopefully you can see the slide. So thank you everybody for coming along to this session. So as it's about creating, the title's creating common set of files for CDR testing and QA. And what I'd like to kind of go through, or kind of want to kind of structure it is a little bit context setting, kind of what we're trying to deal with. A little bit discussion then around what actual data do we actually need. Matt then is going to demonstrate some of the things that we do, or some of the issues we have around creating and manipulating data within Glasswall, and then a little bit of discussion of potentially ways that we can either automate the collection or creation of data. May get a little bit off track, but that was kind of our thinking of kind of what we wanted to cover, because besides, I think the actual having this common set of files, I think we kind of look at it as also as an opportunity as a test team to kind of get some feedback about some of the testing issues and some of those data creation issues, and kind of explore those a little bit as well, because it's one of our big challenges within our organisation. So first of all, sort of, the context setting. So yeah, having that common set of files is one thing, but also it's kind of having a good set of data internally is actually really useful as well. We just had a really good session with, talking about some of the ways to collaborate with some of our competitors, because I'm from Glasswall, and that was a really, really good session. Really kind of set home that actually we're all in the same boat, got a lot of common needs. But this is kind of, I've kind of created this slide kind of illustrate as some of the requests that we as a test team actually get for data, and it kind of illustrates the types of data that we actually get asked about. So one, the top one is, can you provide some sample data so I can test your application? This is usually a customer request. They just want to be able to validate either that actually if we do what we say, or that their implementation actually is doing what it's supposed to be doing. Next one are down about, do you have files with Unicode file names? And that's usually about some encoding issues and just trying to make sure that actually the applications do stuff across the various encodings. Whether it's just a standard kind of ASCII formats, or whether it's a larger ASCII, or there's a whole load of issues around there for test data for CDR. Next one, do you have some doc files with review comments? So this is usually kind of around the types of requests we get, is that somebody wants data with specific content, or specific functional content. Review comments could be one, it could be macros, it could be hyperlinks, it's those types of things. So it's something that's taking advantage of some of the functionality with that particular file. Next one, which is, have you got any malware files I can use? Is quite an interesting one, because as a test team, we don't actually persist any known malware on our system. if we do want to do something like that, we'll take use of something like Virus Total, drag some data down, run a bunch of tests through it, and then delete it all. Because that way we don't actually have to go through that trying to contain that data for a long term on our networks and kind of deal with all the potential problems or somebody making a mistake. We'd much rather have it for a very short time, use it, and then get rid of it. We can't provide file for confidential reasons. Do you have something that produces this error? And this is something that we sometimes get from a dev team who kind of needs something to produce as an error. And this is kind of also where it kind of indicates that you actually need to have some, besides actually having the data itself, you need some information about that data. What's it contain? What attributes does it actually have? We can do that. We've actually got a database which, if we've run our engine through like millions of files, we can go and find particular issues and provide some data for some of our developers. And lastly, can I get some files that are 2 gigabytes or larger? That usually we get requests for files of particular sizes or greater than this and less than this. And usually this is around some other performance measurement or some other non-functional tests that are going around where don't really care what's in it. It's more about the size. So we end up with really kind of so we end up with about 5 different types of areas of kind of looking for, something that picks up in encoding, particular content, the maliciousness of files, the outcome once we've actually processed it, or the file size to do with non-functional stuff. So they're the kind of types of data requests that we actually get that we need to be able to provide as well. So that's just kind of a little aside of kind of what the types of requests we get, and I think it quite illustrates the breadth of data that's actually required within CDR testing. So one of the things that kind of is think about with this session, what we actually trying to what problems we're trying to solve. So I'm kind of breaking this down as a little bit of certainly stuff. The first one is kind of a bit of a self-interest for us as a test team. We actually need a lot of data, and it has to be quite varied. Some of the specifications for the file types that we're trying to process are very complex, and there's a lot of potential cases that we need to cover and a lot of particular variation. So we need a lot of data kind of to actually cover, to get the coverage across. Data can take a lot of effort to either find or to actually create. Now there are Matt's going to talk a little bit in a minute about different ways to actually create the data, but we know that if we need a lot, we've got to get it somehow. Finding examples of what's currently out there at the moment, there's ways to do that. Finding examples of bad files or creating bash files is actually usually creates a lot of manual effort. It certainly does for us. We're really quite interested in finding ways that we can actually make that much easier to do. Next point is about new updated tools or changes of use by people out in the world. So if we've got a set of data, new tools come along, or in existing tools, vendors add new features, and that creates changes in the structures of the files that appear. So we need to constantly be updating to get those new variations, so we can make sure that our engines actually deal with them. The other things for us is actually handling data is regulatory compliance. So make sure we're not using data that's actually copyrighted. Make sure we don't have data that's actually going to break some, like GDPR because of, having personal data. Also to make sure that we're handling it, like for internal policies, are we adhering to our own internal security policies of how we manipulate and store data. So there's a number of regulatory issues that we actually have to deal with, and sorry for this one. And we need to go and make sure that we're actually adhering to all those, or it's accepted or not. The second set of issues, I think, is probably the ones where are more relevant for where we're trying to get that common set of data files. It's, this is the issues for customers and for vendors. So having, the first point I think is actually relevant for both customers and vendors, which is having that common set of data, but how to implement the implementation of their products. So customers quite often want to know, actually, have you got a set of known set of files with no behavior, so I can make sure that when I've used your technology within my systems, it's doing what it's supposed to be doing. Similarly for vendors actually saying, have I got known set of files that I know what the behavior should actually be. The next one I think is probably more customer related than vendor related, but I still see that some parts, or some interest for vendors as well, which is to be able to compare or evaluate products. How well do they do certain file types? We always know with the various tools in the market, some tools will work with better on some file types, or they'll go further with some file types than others, and then you talk to another file type, and then the position could be reversed. And I think the last one is the big thing for vendors, is to be able to demonstrate maturity of the product. We've had, as part of that discussion that we've had around collaboration between CDR vendors, I think it's one of the things that we realise now is kind of that knowledge of what we actually do is quite limited, or it's actually now quite dated of what CDR products actually used to do and how they used to work. The technology has come on leaps and bounds over the last 10 years, or even the last 5 years. So to actually demonstrate, potentially how it actually works and how it can work in a way that actually gets past people's perceptions of some of the older solutions I've actually seen. So next is, do you want to take over, Matt, and explain this?
Okay, hiya. So obviously, when you need to generate a lot of data, there's a few approaches you can take to get hold of this stuff. Is anybody else getting a massive echo on here?
I think it's you, Greg.
Okay.
Right now?
All right, that's better.
Yeah.
So some of the common ways that people use to do this is using data fuzzing to take a small set of data and to produce millions of files from it, or you can go out and purchase data,
All of these
things have specific issues which make them not particularly applicable for CDR testing.
Anyone else is getting the echo? Because
Yeah, I'm still getting it.
I'm hearing
I'm still getting it.
Yeah. Can we get everyone else to mute? Can we get everyone else to mute?
All right. Can you guys hear echo? So that's just me. Right. Can you guys hear echo? That's just me.
How about now? Yeah, I'm still getting a bit.
Still getting it. Who's that other Jonathan Green? Who's that other Jonathan Green?
Right. I just muted everybody.
Still getting an echo through.
Greg, do you still have your thing shared? You want to try now?
We still getting an echo? Echo.
No echo here.
No, I'm still getting an echo through.
This is really weird because everybody's muted. It's almost like it replays after a second. It's like it replays after a second.
Has Greg still got sharing audio on?
Greg still got sharing audio on.
Also, does anyone have two sessions going? Just like look down at the little at your taskbar.
Yeah, I think.
Are we good now?
Yeah, I think we're good. Can you share the screen again? Was that you sharing the screen, Greg?
Yeah, I think Matt's call might be good. If it's not echoing anymore, I think I might have had share audio again, so that might be what was doing it.
Exactly. All right, here we go again. All right, Matt, over to you.
Right. Not sure how much of that you got then. So yeah, obviously if you need to produce a large quantity of files quite quickly, here are the 3 quickest and easiest ways that are commonly used to do it. Obviously you've got fuzzing, so you can take one file and from that one file you can produce millions of variations of it. You can go out and you can just purchase a large data set from a data broker or whatever, or you can go along and you can start scraping. For CDR testing, each of these have various uses, but compliance testing isn't one of them. Obviously, fuzzing is quite unspecific. You're not going to hit the targeted structures you need, and you're not going to corrupt them in the ways you need to ensure that you're actually breaking against the specification. They're useful. They'll still prevent overflows and things internally if you're testing with them, which is good, but they're not so great for the compliance testing. Obviously, it's also possible to fuzz areas of a file and have it remain compliant. Things like you can fuzz the data streams and stuff, the things that store the actual text in a PDF or a doc file or whatever. And then, because any old stuff can be in there, editing a few bytes isn't going to make much difference. So you end up testing the application rather than your compliance. Other approaches include purchasing data. Some disadvantage with this is that data tends to be produced from the same sources. This makes it very similar, certainly structurally. If the same version of Office has been used to spew out millions of generated files and those files have all been generated the same way, they might have slightly different content, but again, as far as we're concerned, structurally, they're going to be very similar, if not identical. They also won't contain variations of exploits that we need to test against. Things like they are unlikely to contain things like macros or dynamic data exchanges. Finally, the last approach people tend to use for stuff like this is obviously web scraping. It can leave you in a bit of a grey area sometimes. Obviously, you have to worry about copyright compliance and things. So, you know, if you stumble across someone's personal website and they've shared their personal CD collection, you can't really be sharing that publicly. You've got all sorts of copyright issues there. Not only that, but again, hopefully it won't contain exploits on there. Sometimes it does. Sometimes you'll scrape a website and you'll find that people have been uploading malicious files to that to try and catch out the company or whatever. Yeah, and the other things is sometimes people who are doing this stuff are using a third-party PDF or image or whatever generator, and they are building files that don't conform to the specification. Now, this isn't in a malicious way. It can just be a slightly lazily or poorly coded version of whatever's generating the data, or it could just be using an out-of-date version of the specification. Either way, it's not ideal for CDR purposes.
So that was kind of our initial kind of thoughts about potentially some of the challenges around some of the data. I mean, has anybody else got any opening comments on that, or any of those areas?
So I think the fuzzing, and it's an interesting way to approach it, right? Because I've done fuzzing in the past, and I wish I had the object models that we have now, right? Because if you start to base this on top of objects and allow some almost like context for the creation of that data, then we can actually create very, very good data sets with that. And it's almost a mix of clever fuzzing, because you can, you know, like when, not just for the hiding stuff, but also when you start to put in, you know, bad data, because, you know, because you now know where the data blocks are. In a way, the the point of the fuzzing is to actually hit those, is the other bits, right? The ones that are not data blocks, the ones that, you know, actually mean something. Although it's also interesting to put bad data into the data blocks, because by definition, they should just fly through. And then when you connect this to the ISGs, I feel that there's a very interesting meta language here. There's a very interesting, like, you know, those JSON files that we were talking in a previous session, where, you know, we should be able to say, here's a particular issue that we're trying to address, here's the security implications, and here's the places on that meta object, on that, you know, object representation of the document format that you need to put the payloads to trigger that.
So you actually think that that's potentially a way forward for us?
Yeah, absolutely, right?
Yeah.
Because when you look at a lot of fuzzing, right, you know, and it's interesting because there was a lot of good successes on the fuzzing industry, right? There was a couple of good, you know, fuzzers, etc. But the biggest challenge they always had was to be able to know where to put the payloads, right? Know where to fuzz, because, you know, even realistically, right? You know, even when you're fuzzing blindly or you're fuzzing with certain things, you have to have context, or else, you know, even a simple, you know, 1,000 file or 3, 4, 5,000 K files, you can generate gigabytes, you know, or terabytes of data just based on one file, right? Depends on how you fuzz. So I think the more context you have on what is supposed to be happening, on what the valid formats are, the better you can create bad, you know, in a way, or files that don't conform to that, or files that allows you to check if you're actually doing specific things.
We did actually make quite extensive use of fuzzing back in the early days when I first joined the company. And it was, you know, quite a useful technique earlier on when we were trying to get, like, you know, the basic structures down and things. But really sort of random hits on things, limited use, to be honest. I'm not particularly enthusiastic about it unless you can fuzz things in a smart way that specifically target particular structures.
Well, that's the thing. You can start to then think about how to do that in a much more efficient way. But also remember that we're now at cloud speed, right? So things that in the past sounded insane now are realistic, right? You know, the idea of creating gigabytes or terabytes of files sound, you know, insane when you had to actually get, you know, disks and that kind of hardware, where now we can spin that up, right? In a cloud environment, we can generate those files, store it if we want to, pass to the engine, then destroy the whole thing in one go, right? And that's just part of CI.
What about testing against other, like, parts of other file types, just as a kind of like turn them into almost like a dictionary attack where you're running it against, in a sense, it'd be kind of a combination like that. So
one of the things that at least I think our engine does, it'd be interesting to see, you know, other engines, how they approach this, is my understanding, and Jonathan, please correct me, is that we actually use the object model of a file to determine the file type. So the first pass is actually determine file type. And that tends to be very accurate because, you know, we're not looking for magic signatures. We're actually looking for structures.
Right, but I mean, not necessarily the components that would make it a specific file type just by themselves, but the random parts that would be a part of that wouldn't necessarily, how do you explain that? Like I'm going to think of a better way to explain this before I try to bumble on about it.
If we don't, Wallaby, I'll try to remember to come back to you on this point.
And any other comments from the other guys on the call? All right. You can also use the chat if you want. All right, keep going.
Yeah. So the next kind of thing that we kind of want, the next part of it we want to do is just have a bit more of an open discussion around whether it's for our product, other products, or as a shared set of data that's publicly available. And this is kind of a very broad question: what data do we need?
Well, I think even going continue the conversation we had on last session is we should start with a common set of files, right? It's almost like if you pick the key functionalities that we are after, malform files, files with macros, JavaScript, metadata. It's almost like go down the list of the key features of CDR and have a suite of files for each of those use cases. And I would go back to the idea that each of those should be backed by an ISG, right? An item on an ISG, right? Somewhere down the line, there has to be an ISG that says, don't do this, don't allow this, validate this, do that. And just having that first table, I think will be a massive success story, right? And we'll that means that we're not talking about, dozens of thousands and hundreds of thousands of files. I think even if it's a small block of 100 or 200 files, that is already a great first step on that direction.
It's an interesting question. So, like, when we talk about having the conversation, it's like, that interesting sort of thing, like how much is enough? It's always an interesting. Right?
So, when we have 0 on a public domain, well, we have 4 or 5, or maybe 7 or 8 on our site, and a couple of other sites have a couple, right? Like, if you go back to your use cases, at the moment, everybody's starting from a blank slate, right? So. You anything better than that is an evolution.
Yeah.
I guess my question. Oh.
I think, to be honest, from our sort of previous experience, the issue has been less one of what data do we need, because we've historically had tons and tons and tons of data. It's how do we categorize that data in terms of what its characteristics are. How do we select data on the basis of, I'd like a couple of 100 files which have got macros and bitmap images in a particular format or whatever, and are of a size between this many bytes and that many bytes. So it's like sort of it seems almost like more of a cataloging problem than a gathering. The data's there's tons of it about. It's just being able to actually select things with particular sets of characteristics.
Well, fundamentally, that's quite simple. That's no more than having it all fed into a database.
And yet we never seem to have done that.
No, we've got that. That's live.
Okay.
Yeah, I think historically, like Jonathan says, I think we have fixed so many issues and found specific data sets that that we're resolving against the bugs, but I think we've been very poor at trying to capture that set and pin it down to specific problems and enrich that set.
And this is one of the interesting things about, at least kind of like to peg it against the ISGs, it kind of gives a benchmark, a potential benchmark for one of those, but to say, yeah, you kind of deal with that. But even to, if you take a one of those single requirements out of the ISGs, quite often you're not going to prove that you're doing the right thing with one file. Now, some of them, you've got to draw a limit somewhere. It's especially where you're dealing with, like, are you rejecting invalid structures? Well, there's so many different ways of actually doing an invalid structure. You can't test all of it. You still want to have a good, robust set that kind of gives you like reasonable amount of confidence that actually any engine that you run this data through, yes, it should reject this particular, it should behave in this particular way, or we expect it to behave in this particular way. Does it do it? And you're going to need a number, and I think that's going to be quite a hard thing to kind of work out. What's the minimum size that you actually need to do that? You could say it's 1. I personally wouldn't feel very comfortable about that, from a QA perspective, to say, yeah, I've run it with 1 file and it did it okay.
Yeah, but that's a different problem, right? I think the problem of coverage and completeness and how much is enough, right? That's, you need the infrastructure in order to do that, right? And at the moment we don't have the infrastructure. We don't have a common set of files. Look, when I started, I had the exact same problem. I was like, hey, where's the set of files that I can use to give a good test drive to the engine so I can reverse engineer in my head what is going on? It wasn't a simple exercise. And if you go back to where the challenge that we have, which is a large chunk of the industry doesn't understand what we do, and part of it is because they can't test it. So how can somebody gain trust that our engine does what it does if almost they don't have the two fundamental bits, which is a great set of files to test it and actually an engine to run it. Now, I think we solved, and some of the players now have solved a little bit the openness to have easy access to an engine that at least you can drop some files and get the results on, which is great. But the data sets, let's start simple, right? Let's create a set of data sets that can get more, almost they can be more and more complete as we keep evolving. And I think Jonathan really hit it well nail on the head, which is this is the data classification problem. It's about finding a scalable way, a database-driven way that, and call me old-fashioned, but I prefer everything should be on the GitHub repo, and then you rebuild from there. So the GitHub repo is the database, right? And then you have metadata, and you have the files, and then basically from there you build your test suites and you build your consumption. But the classification is key, because the classification is what actually allowed you to create automation on top of this.
And that's where I think also the place of it is the metadata is actually really key as well.
Oh, absolutely. Yeah. Oh, yeah. Look, a very simple question, which is how many CVEs are protected by CDR technology? And I don't have that answer.
Mm.
And that's almost, you could argue that, if from the outside, I would argue, well, if your technology is so good, show me all those examples, right? Because I know we don't look for badness, but there's cases where we have known badness once the file has been weaponized, and if we make it good, then where are all the CVEs, right? Where are all those examples of the files being converted? And this is not about chasing the ambulance, right? Like we talked the last session. It's not about being the kind of industry that every time there's a new exploit, we run around with press releases saying we can do it. But it's about looking at the evidence of the last 5 or 10 years of malware and exploits and be able to prove that the technology does work in there.
Mm. Yeah.
And I would argue that as a consumer, it's almost like if you haven't provided that information, either your technology doesn't work or you're not mature enough. That kind of, being a bit blunt, right? But it's one of those, right?
Yeah.
Because why, think about it, if the technology works, why wouldn't you look at the last 10 years of and known use cases? Like you said, the Virus Total has piles of them. We have examples of files, there's tons of files that are public domain that contain those exploits, that contain those things, that contain those situations. Why don't you publish that, right? I think that's a very valid question that is made to us as an industry.
Mm. Yeah.
And some of these will, you game the file a little bit, i.e. look, this is not malicious, but it has that property which is used on malicious files. So in a way, you needed 2 sets. You need a set of real malicious files that, you have to handle with care, but they're there and they show, and, you're running on sandboxes, you're running on certain, protected environments, but you can actually see that the engine does work and you can open it safely. And then you have a whole suite of files that prove almost feature by feature that you do what it says on the tin, right? And when you don't, that's fine. That you just found the gap, right? And the gap is either a bug in the engine or a limitation of a particular engine. But, for a lot of customers, that might be okay, right? Maybe, you don't do images, but you do PDFs and Words. That's great, The users
here's a question.
Are there, then, the customer get to decide then on the level of the protection and the level of completeness of particular tools, if they're happy with those limitations, right? Sorry, Robert.
Sorry.
Yeah,
Hi.
hi. This is Oren. If I can contribute, I tend to agree. Yeah, my name is Oren from Sasa Software. We're also a vendor in the space. I tend to agree with what Dennis is saying. There are a few different problems we need to solve with these data sets. I mean, there's the problem of a data set for internal usage. I think it was covered well. There's the problem of when a customer is asking for a data set. But basically, I tend to agree with what Dennis said, is when you try to demonstrate effectiveness of the solution, then you need to do that in several dimensions, where one of the dimensions might be showing that the file does not have artifacts and maintains usability. So you would want to do that. Another dimension would be to select like an exploit or certain methods of attack, and to show a file before and after, and then to demonstrate in different ways that that exploit was indeed removed. So there are different use cases where you would want to do the demonstration, and from my experience, it also really depends on who you're talking to on the other end. Because if it's somebody who doesn't really understand the benefits of CDR, you might go with one option, and if it's a more technical discussion, then you have to go to a more in-depth demonstration. But yeah, but basically do something that's relatively easy to show the effect that is done. And then if a customer wants to do a more in-depth penetration test, then they need to provide a data set for that.
It's very, very interesting in the two dimensions you actually mentioned, because in the session we had a little while ago where we're talking about collaboration between sort of CDR vendors and some things they do, it was kind of, and how we have that common benchmark, it was those two aspects of the usability of the document after it's gone through the engine, and then the potential or the removal of exploits, or the safety of the file after it's actually gone through. Was kind of, there was quite a lot of discussion around that of because I think that, you know, we all said, look, is if you can make, you could probably make one of them 100%, but then the other one will suffer. And that's the thing. How do we actually kind of get that point across? And potentially you need a different set of data to kind of show those different aspects, depending on the customer.
It was a little hard for me to hear the question, but I just have a hearing impairment.
Apologies.
Yeah, that's okay. Yeah, and I'm also calling in from while I'm driving, so I stopped on the side. So it's a little hard for me to hear the question. If you can type it in a chat window, I'll be able to reply. And if there were previous discussions, I'll be glad to review them and take a look at that and contribute.
Okay. Try to moderate how I say things. So it wasn't necessarily a question. It was more of it was kind of a recap of the discussion that we'd had in the previous session.
Oh, okay. Thank you.
I'm just looking at the question from Wallaby, so I'll just read that out. Does the ISG define the difference between the file types as it pertains to security? So do you want to speak, Wallaby? Or sorry, now give you a chance. I know you've been trying to get in at several opportunities.
Oh, that's fine. Yeah, I was just asking, the ISG seems to define in a very special sense the file type as it pertains to security. So if that's the case, then, you know, in order to actually test it, you would be testing it against kind of the other file types or parts of the other file types, right? Something that would open up and run as something else, or something that would hold something or contain something malicious in some part or another. So basically what you would want to do is just create something that systematically breaks the rules of that ISG definitions. Okay, so then that's not going to be that hard to generate if you just have sense, right?
Sorry, I think you broke up a little bit there.
You have what?
you basically just have to set it up kind of as an adversarial network, right? Where it's learning, it learns from itself, but uses the principles to break the rules.
Now that's an interesting thing. Could we use an ML engine, right? Not to go on the AI stuff, but a machine learning engine that creates files, and based on the output and the inputs, right? Based on the actions, modifies the original file until he finds one that makes it true.
And just keep it separate, right? That's it. You keep it separate from the outside one. Keep it internalized so that you're not, creating something that you don't want to be like.
But I think in this case, I think the file type thing, right? At least look the way
contained environment.
Yeah, the way the engine works, right? I think I think most of them probably work the same way. Is that the first pass determines the file type, and the reality is that in the case where you merge files and you put things that are not supposed to be there, the point of the engine is to ignore it, right? So the engine will ignore a bunch of stuff that is not supposed to be there, because when he recreates the file, he recreates the file based on the known spec. Right. So, and that's what you have with polyglot files. So if you look at polyglot files, they are files that are at the same time, they are a GIF and a zip file, or a GIF and a HTML file, or a PHP file and a zip file, right? So they basically at the same time, because of the way that some of the file formats are designed, they are valid on using multiple extensions, i.e. in multiple scenarios. But the way the CDR engine will operate is they will, once they agree on one file type, then you process that file according to the rules of that file.
Yeah, I think that's kind of the thing, though, is testing it against slight variations that would allow something else.
So when Matt was talking about fuzzing, and when I was talking about fuzzing, that's exactly what it is, right? So fuzzing is about
given a rule set.
Right.
It is, but it gives it a rule set, and that rule set is based on the other file types as defined by the ISGs.
Yeah, yeah, I'd be interested to see that in practice. Like, the different file types, right? Is like they would be quite different. Like basically you want to fuzz based on the file type definition, because the further you go against the file type, the more things will be ignored, right? So if you slap in a PDF section inside a JPEG, right, the whole PDF section would be ignored, because the engine, you need to think of this as an object model, right? Right, as the engine is parsing and is reviewing the components of the JPEG, right? If there's a massive blob in it, and if that massive blob comes from a PDF, but if that doesn't make sense from a JPEG point of view, or it's just a bit that the JPEG, spec says to ignore, then the engine will completely not look at it. And Greg, correct me if I'm wrong, that's how our engine works, right? Or Matthew, right? Or Jonathan, sorry.
Well, or worse, that could throw off one of the compulsory offsets that would potentially overflow somewhere, and then the class will just reject it.
But yeah, I mean, I think if you sort of have a chunk of PDFs just dropped into the middle of a MP3 file or something, then at that point it will immediately, at some point it will pretty much definitely stop complying with the rules for whatever the external file type is, and either the parser will choke on it, or it will be flagged as a chunk of extraneous data for removal. It's pretty much how the thing works, really.
I see. Okay.
I mean, it would just, it's looking at data in a particular context, and if you're looking at, a piece of data in the context of expecting to be reading a PDF, and you find a chunk of an Excel file, then it's simply not going to make sense, and the parser is very quickly going to fail.
You need to work against the spec while following it, really.
Yeah, I mean, targeted fuzzing, sure. What happens if we sort of aggressively attack, this block of data? I mean, that would be a very cool thing to be able to do. But I think you know, randomly putting bits of one file type data in the middle of another file is, well, you know, it might be interesting to do, but I certainly hope it would have limited utility.
Okay, fair.
Cool.
I would
So-
say the caveat, potentially only caveat around that, but it's not necessarily parts of files, it's probably whole files, isn't it? Because we know that there's quite some other things that are legitimate cases of one file embedded in another. We talked about the Polyglot one, which is not, you know, it's because it's hiding something, but we know that there's some genuine ones where you actually have got a file, you know, classic example, you know, an image in a Word document or in a PDF.
Yeah, that's kind of what I was thinking about, but at the same time, you're right. That would be more compressed, so it wouldn't be something you'd be able to really get to that easily. If you tried to decompress everything that came through, and if it went along, and if it didn't create or didn't cause anything like to come from it, I guess in a sense that's one way of being able to tell if, you know, if there's nothing there as you decompress it, just as a, I mean, it wouldn't be, I don't know.
Yeah, it's kind of, I mean, I mean, it could be, I mean, there are a number of things that you'd want to do, and I think the ISGs become a good, they become quite a good sort of thing to do it, because it does mention a number of times where actually you should be looking to see, has somebody inserted a bunch of other stuff in here? So it doesn't particularly matter what it is. I mean, it could be it's something that's quite specific to another file when you're trying to do that type of testing of, okay, I'll put something here that shouldn't be here, because it comes in. It comes a quite an, you know, you kind of get the thing of say, yes, we've definitely proven, because it's just thrown it away and not really looked at it, that it hasn't kind of somehow tricked it to make you think that there's something else there that should be there.
Yeah, that makes sense.
Look, and I think I really like that definition, that the ISG should be the master for the definition of the safe definition of the file. Sorry, the ISG should be the master of the safety of a file, right? Because, you know, you can have things in spec that are unsafe, but you should have everything that the ISGs ask you to do should be related to security. So if there's any security side effect that we are concerned or somebody's concerned, it should be covered in the ISG. And if not, that's a bug on the ISG, it's a blind spot that should be addressed in the next version.
I know it's a kind of a bit of a slight digression, but it kind of leaves us, it kind of gives us a bit of a hole because of the other dimension that Oren mentioned about the usability of the document.
But that's different, right? You know, yeah. There's a difference between you having a good set of data and a good set of mappings, and then the abstraction layers that you create on top of it, right? So the bottom line is that you have you create abstraction layers within the abstraction layers within the abstraction layers. So, you know, when you look at a fridge and it has 5, you know, what's it called, energy saving mechanisms, right? That has been normalized to a very simple matrix from 0 to 5, right? But if I want to zoom in, I can go, what do you mean by 2? And there'll be a massive another set of tests. And I'm pretty sure that each of those, you can drill down into another set of tests until you actually hit almost the physicality of what you actually are doing. But the problem is we don't have that base, right? Which is what we want to do here, right? So what we're looking here is to create a set of base and a framework that works for small set of files, but also works for large set of files that we can use to basically test the engines, but also prove and allow others to evaluate and to test the engines, right? And eventually communicate with us, right? Because this same framework can be used for somebody who has a bunch of tests that are not working correct, files are not working correctly. This same framework will allow for that to be created.
Yeah, quite get that, but
Well, look, imagine, for example, that we actually are collaborating more heavily with one of the vendors of the products, right? The file formats, right?
Okay,
if
yeah.
you're going to push a new version of the file format, you can create a set of files that represent the changes.
Okay, yep. Yeah, okay.
And you
Now,
have
now we
a
do.
test suite that just represents that.
Yeah.
So I think, like Jonathan was saying, the question here is what data classification do we need? Hey, Jonathan.
Has anybody got any thoughts about that then? What do you think would be a good set of if classification for types?
I mean, like the ISG would be the first obvious one, right? You have a suite of ISG compliance testing.
There are two things that are going to drive it, really. One is obviously the ISGs, the second are the definitions of file types themselves in terms of what kind of objects they can contain, what kind of things can be embedded in them. So, the intersection between those is what we need.
What if we started looking at different data type or data that could actually be used for testing that has for different different things? Like actually I could what we find and then go from there.
Sorry, Wallaby, I'm not sure if that was me or you, but you were breaking up a little bit there.
I think it was, Wallaby, can you replay that?
I was saying that what if we took a data set that's already out there that is used for testing and just see what their methodology was, where we can go from there. I know there's one study that that I have directly in mind. I was actually starting to look through some of the data they had, but I don't know it would directly relate to anything. I would just have to see. But actually looking at the data sets, though, that are out there for testing.
You're talking about vendor supplied test test data for basically for the applications.
Yeah,
out there again. It's quite possible that some file types may actually have sort of qualification test sets, which the publisher of the spec provides to to assess compliance. In which case, yeah, that would be brilliant. It's not something I've looked into, but it seems the sort of thing which standards bodies might do, and if they do, then yeah, great, leverage it.
Well, hopefully that would give us some happy path testing.
We might be looking at different academic papers as well in that sort of area. See what people have looked at and studied from that direction. I think that might be something that also could be of value.
There's probably quite a good piece of academic research for somebody there in terms of actually constructing some sort of global taxonomy of data and the things it contains and things.
Yeah. I mean, we talked about some of these other methods, like fuzzing, data scraping, and stuff like that. Just go out and look to see what we can find. So, there might be something else. I mean, we definitely got representation here from a couple of other CDR vendors. But the two Orans. I don't know whether either of them have got any, if they've seen any sort of like published data sets or aware of anything. Okay. So I think so I think that the kind of sort of like to sum up the little discussion about the discussion about what type of data do we actually want. It's down to some form of classification model, start primarily with something that matches the ISG, so that we can kind of say, yep, if you do this, you've got a safe pathway through whatever your whatever the engine is, or whichever particular product you're using. If you comply, if these go through, you should be reasonably safe. No, we can't be 100% safe, but it's kind of a start.
While I've been listening to this podcast, there's a few points. I've had this idea sort of flicking through my head of some kind of like analog to VirusTotal, acting as an actual sort of clearinghouse where people could, you know, submit files and, you know, firstly, potentially put it through a variety of CDR engines to see how it deals with, and secondly, if they had a material which they considered might be problematic in terms of whether it could clear particular kinds of unwanted data out of it, or whether it would survive in an intelligible, renderable, usable form. You know, people could actually sort of submit stuff, at which point you get, you know, a community doing a lot of the work for us, and you know, it becomes a valuable resource for everybody.
Yeah.
Crowdsourcing it. That would probably be the thing to do.
Yeah, I mean, I think, you know, you take VirusTotal as your model. How easy it would be to set something like that from scratch, I don't know, but you know, immediately you've got a central clearinghouse where people can, you know, submit, you know, potentially problematic files or simply stuff they're interested in, seeing how it's handled, and well, away you go.
That is quite an interesting concept, isn't it, of what it would actually take to actually do that. I think it also starts to come of one of those things of dealing with some of the issues of how you kind of explain what CDR does. That's, as you were saying earlier, that's kind of one of the challenges is people not necessarily knowing what CDR does, and if having something like that is yeah, it does seem to me that there's potential. You know, I think there's quite a lot of potential of that, especially if it's supported by multiple vendors.
Yeah. Which is, you know, they kind of the sort of thing I had in mind when I talked about, you know, some sort of, you know, potential, you know, sort of industry body, certifying body, or whatever. You know, the sort of thing you could do would be like, sort of like, you know, run sort of some global education on what CDR is and what it does. You know, provide sets of files, you know, for people to, you know, sort of measure the performance, and you know, also act as a clearinghouse for, you know, sort of data which, you know, people wanted to submit to, you know, potentially become part of that test set, or to see tested for their own purposes. And it's you know, potentially a big thing, but you know, everything starts somewhere.
NA in the chat has made a point that obviously having a lot of good files being pumped through for a CDR vendor isn't the most helpful thing in the world. We are looking to put through as many files which are non-conformant to the spec as possible, as opposed to the conformant ones.
Yeah.
Which is why we were discussing the idea of having a fuzzing algorithm which can directly fuzz items that need to be specific values or offsets or whatever in accordance with the ISGs.
Or some sort of central clearing house where people could submit files which either had been shown to cause a problem with, you know, one or other CDR vendor, or which, you know, they were concerned might for whatever reason.
Look, I think the key concept here, right? And then, you know, and there's, you know, several concepts here. First of all, I think the idea of dimensions that or was mentioned is very interesting, because there's definitely a number of dimensions here, like from a business point of view, right? Where at that moment in time, you're not really looking at very malformed files. You're looking at certain core functionality that is almost visible by hand, right? You can just open a file. There's a macro, no macro. There's JavaScript, no JavaScript. There's metadata, no metadata, right? So I think there's a level of functionality that we have that you could almost test it by hand, which is important, right? Because, you know, you trust that, right? You see it. Maybe another level where you actually need a binary, you know, tool to compare the two to see it. But to address the point of NA there on be careful if you're not testing a large amount of images with the same thing, or you're repeating the same CDR capability. That's where I really like the ISG, because if you look at it, the ISGs, at least the ones I read, they were all focused on a particular part, right? So the PNG, there's the bits that are worried on the header, then the bits that are worried in the middle, and the bits that were at the end. And then there's this part here and section there. So in a way, you probably need a good set of use cases, but you might not need, a lot more than 5 or 10 per area that basically prove that whatever the ISG is saying on that area is having. So now what you're not going to do is you're not going to fuzz and generate, millions of files for one area where probably those 10 use cases address most of it. In fact, I think the bits that are worth fuzzing are not the bits that you put a lot of data to it, are the bits that act as control. How many sections you have, how many, parts of this actually exist. Let's put character zeros in the middle of strings and see if that throws any of the C++ parsers off the window, right? So, the ability to programmatically create test cases actually allow you to create a suite of files who are laser sharp focused on specific parts of the ISG and actually reduce a lot the noise of lots and lots and lots of dumb fuzzed files.
Yeah, it's deliberately going against the validate clauses in the ISG, right?
Yeah, exactly, right?
This is Oren again. I would like to expand a bit on what Dennis just said. So really, again, on that topic of demonstrating what CDR does and maybe relating to this previous conversation. So let's take the example of what you said of images. So one really simple technique that I sometimes use is take an image and put a steganography attack, like a stego code inside of the image. Like a string from some ransomware or whatever, something that if I would run it on every other file, the AV would jump. Really, really simple, and encoded without any encryption, nothing at all. But then this is something that I can visibly and really easily demonstrate what is going on. Of course, and it's a really stupid idea for us as professionals, but sometimes the barrier is, even if I have an IT professional in front of me, is to choose a few select families of demos like that that are really easy and really tangible to demonstrate. Here's the file before it was reconstructed, and here it is after, and then take the more complex data set that we're talking about to later stages. But the most challenging part is often to demonstrate that initial effectiveness, if that makes sense, what I'm saying.
Perfect sense.
I think it's spot on, right?
Yeah.
And I actually think that is a really great case study, because what you're then showing is showing, look, here's a signature that, for example, some other engines will jump and say, hey, look, this is a problem. But, in our case, we'll ignore it, or we just go around it because we're not looking for that pattern, right? And I think that is a really cool example of picking a use case that is easy to understand, is easy to replicate on the other side, but also proves, how the engine is working.
Exactly.
So I like that. And look, and that's the kind of things that, we can collaborate, right? And actually, I actually feel that we're missing a trick by not getting the security community involved in this. Like, where's the guys presenting at DEF CON in Black Hat, right? About this kind of stuff. They did for a while. And I think they all, after a while they gave up because there was no good solutions around it. But I think there's some really cool security exploitation and research. And even like, playing around with all these file formats and these kind of attacks that generates a lot of energy, that generates good technical information, and actually shows, the power of the engines. And if they find a blind spot, great, because we'll just fix it, right? So Oren, I guess we can put you down to provide some of those examples.
Yeah, I'll be glad. I'll send you a message how you can contact me.
Cool.
Send a message. Okay, cool.
Thanks very much, Aaron.
You guys can continue.
Yeah, I was going to kind of part of that was trying to say, I in one of the raised what NA said, I kind of agree. We do need to have those good examples as well, because one of the things we just need to make sure that what we're actually doing is when we put stuff through the engine is that we don't break things that shouldn't be broken. So that was. Have we got any further comments or observations about the type of data that we might need?
Just a real quick point on that. If you insert good files, you probably want to keep them separate from, so that it's not teaching, you know, basically you want to keep it separate probably from the engine that's actually processing the bad files. So you run it against this. If you're not teaching anything, you're not teaching anything. So never mind.
Well, the only comment I will go there is that we actually should come up with a protocol for handling malicious files. And I think it's even something as simple as zipped and encrypted,
Yeah.
Right? Because like you said, Greg, you know, I share your concern that, you know, you don't want, you know, lots and lots of piles of malicious files hanging around, right? Just waiting for somebody to click on it, right?
Yeah.
But so I think there should be a protocol that, again, we get to define to say this type of malicious files, you basically always need to store them, you know, it's like, you know, what's it called? Biological, you know, containments, right? You know, you want to make sure they're inside a container of a container, like, you know, you just don't walk around with them in your pocket, right? So. Yeah.
And that's I think is, you know, we should also do it. I mean, having it there and available, and I agree we have that protocol for storing it. And I think we should also, as part of that, give something in there, you know, wherever we store it, is given advice on how to handle it and how to contain it, so that what you know is if somebody who is not necessarily strong on what they're doing has got some guidance on how to actually use those particular files. I mean, hopefully that you know, hopefully they're you know they're an IT professional, but they may not be.
Well, some of the issues around tests on files like that are automating the value from it. A lot of the times we've seen instances where we'll take a file with malware, strip it, upload it to VirusTotal, which will report it as still having the virus in it. Then we'll pull it back down. And what has happened is we have removed the payload, but the conventional antiviral things have latched on to and produced their signature from the trigger. And where we've left the trigger intact but removed the payload, then we get a lot of false positives. And this produces issues for us when we're demonstrating value against malicious files.
Yeah, but that's just something that we need to have use cases for, right? In fact, I think what I was saying is to actually create some more examples like that, where we can actually almost reverse engineer why we're having those false positives, right? You know, it's almost say, hey, you know, here's a document that has 10 components of malware. What we've done was, we removed the weaponization of it, but these 4 or 5 things, which are now also seen as signals by some of the AVs, we can now say that those signals are wrong, right?
Oh yeah, I'm saying that's a good thing. The issue is around automating that process, as that can be quite manpower intensive.
Yeah, I think the automation of this is always like, you know, at the moment there's places, you know, where automation works, and at the moment, you know, it could be a case where we're actually writing some of these tests manually, right? It's okay, right? You know, it's still more efficient than testing manually, right? Writing tests in a manual way that check for specific things, especially if you build on top of a DSL or an API, is still way more efficient than a manual test. And the good news is that once you write that test, you get to run it all the time. Because that's like something that we've not covered here, which I would like to see, is I would like to see unit tests that actually, and integration tests that are the way this gets executed. Because for me, the common test framework is a test framework. So we shouldn't be reinventing the wheel in some of these things. There's good frameworks in Node, in Python, we can pick them up. And some of these can just be, you know, all the test framework is doing is actually executing a suite of tests. And then we can get to the next level, which is when you write the tests programmatically itself. But let's not get there yet. But the test framework is also quite a powerful way of doing this, because you already have, ways to measure it, ways to run it, right? There's common ways to run test frameworks. They are CI friendly, so it's a good way to measure that. And they provide good reports. So that industry is mature.
So I just found a study that is looking at, and this isn't the one that I already posted on there, but this one is looking for new families of malware, kind of a certain distance from any current families of malware that are generated. Anyway, sorry, I just froze up here when I was going to read a part of it, but I'll just drop it in the chat here.
Yeah.
It might be worth looking at though, because if we're looking for something that, well, if we can base it off of what we know to be something that we want to take out and just change it around the principles that make up that particular aspect of the file, then it might make it easier for us to somehow narrow down what it is that we're going to be using versus just trying to use everything, I guess. But the first one though, I put what it was right there. But the last one there that I shared kind of relates to that a bit.
And I think it's kind of still that thing of, isn't it, with creating that initial set, isn't it? That's always still just the problem, whether it's manually or whether it's something a bit more advanced.
Yeah.
We need to share that with Petra. I suspect you'd be interested in that. Okay. Any other further comments on the types of data? What data types? So, one of the other sort of things, this is a kind of a little bit of an aside, and it's kind of, I think it's one of those things where especially with the two orange, Orange Schnitzer and Unresolved Skin here, it's kind of interesting to kind of get their feedback, some of the issues that they have as well. Matt's going to give a quick demonstration of kind of some of the ways we actually do to create some of the files and how we manipulate the files. And because I think from us, it's like, this is something that we end up doing for crafting files individually. And if anybody's got better ways of doing it, because what we're doing, it's very labor intensive. It's not the great way to do it, and we're quite happy to do it, but it does give us something that's custom built for doing it. So just going to give that quick, Matt can give that quick demonstration and then get some feedback of really, I suppose, from anybody who's saying that's really rubbish, or actually there's a better way to do it, or no, that's exactly what we do as well.
Right, I can't tell. Can people see an ISG specification?
Yeah, it's there, man.
Cool. Right. I'm going to do this on the most basic thing I can possibly do it on for quickness. So what I've got here is I have the PNG ISG specification up. I've gone to literally the first thing in here. It's a very simple, easy one.
You're on mute, Matt, if you're kind of speaking.
I think we lost the audio for Matt.
Hello?
Yeah, you're back.
Sorry, it's my first time presenting on here.
Got to mute again, but
Hello? Right, am I audible?
yes.
I can hear you.
Cool. Right, now I just need to reshare again. Right, here we are, back to where I was before I got lost. Okay, so just the most basic way, so as you can see here, it's a very basic validation. First 8 bytes are equivalent to this. So all I'm going to do is I've got a basic PNG here. I'm going to open it up in a hex editor and break it. Oh, of course. And I'm going to break it. Cool. So the header is no longer conforming to specification. Test it just by bunging it through the engine quickly. Check the process log. And we can see that it has failed because we couldn't detect the file type because it's been completely nadged. And that is, in a nutshell, the quick, easy, basic way for this example anyway of breaking something against the specification. Obviously, when you start on things like Microsoft Office documents, or you just move away from doing the simplest test possible of just corrupting a header, it gets significantly more difficult when you move into things like tracking down offsets for a particular stream and breaking those. But yeah, that's it.
Isn't that kind of where machine learning would help some? Because you're not wanting to fuzz it just where it breaks like a structural part. You're wanting it to be, you know, slightly outside of that and be able to have some sort of measurable distance. And that way, actually, it could be able to run it against its.
Sorry.
Yeah, so can you hear me?
Yeah.
Yeah.
Yeah, so that's cool, right? And but what you need to do now is do that programmatically.
Yeah, and that's what I'm hoping to get to the bottom of it. Obviously, as it came out organically earlier, using smart fuzzing, whereby you can pass in a specification, a set of rules, whereby you've got an offset, what the value should be, and let a fuzzer break those values to outside of what they should be, would be a
Yeah,
good
but
solution
again,
for doing this.
the way I look at this, right? That is you escalate that dramatically, right? At the moment, what you showed was you did a manual open of a file, a manual change of a file, a manual execution of an engine, and a manual confirmation that something different happened, right? So before you even go into more fuzzing things, you need to automate just that part.
Right, that's the
Everything
first step.
outside of data production is automated. This is just for the sake of the example here.
No, but that's what we need as a community, right? So we need to have a standard way that if somebody wants to write that test, there's building blocks or APIs that we can publish that allow that to happen, right? And in fact, I actually think that what we also need, we need an industry standard way to verify the file on the other side. So because you need to think about like because of the engines, and this is a limitation tomorrow, although there's an open source that we're good to play with, but because the core engines are proprietary in this case, although we might be able to pass it to the public version of our engine, but the main point here is that you need a test that is executed against the final created file and confirm that file, right, is actually doesn't have the stuff in ASG that says shouldn't be there. right? So, and in this
Yeah,
case,
this is that was a big subject of a lot of the talk last week, wasn't it? If you go back and listen to the ISG ones with Stephen Warner.
yeah, but that's the case here, right? So the case here is when you look at, these, and macros is a good example, right? So we need a mini tool that very simple answers the question: does this file has a macro? Right now, we might be able to do it differently because we might use our engine, but there might be other ways, and there has to be other ways to verify that. But if you want to have a process where we have a pile of files that we have published as a community to say, here are all different files that have macros, here's 20 files that have different variations of macros in multiple versions of the documents, you also need an independent way to verify that the macros are not there or are not in the generated file, right? Now, the fact that an engine goes through or not, that's what each engine will do a little bit differently, right? But the test cases are, in a way, here's a suite of files that, we will use for our tests, and here's a way to verify that the file at the other end actually meets these particular properties.
I kind of get this kind of an interesting problem because it's because we want to have that independent verification, doesn't it? As you put it through, you get something, you get the right result, and then you kind of almost kind of saying, yeah, to actually get that detection, you end up almost effectively writing something that's not non-vendor specific, that does effectively what some of the engines do.
Yeah, I almost feel like, it's kind of like when Simon Worley, if we were in that session where the guy says, don't go to PSTs and don't do Pioneers Town Planners before you do the doctrine stuff. I almost feel to say, let's not talk about fuzzing and AI and ML and all that complicated stuff until we actually have the foundation blocks. Because we at the moment, we don't have foundation blocks, right? We don't have simple data sets. We don't have simple ways to verify this stuff, right? Where basically, and they're not very complicated, but they are, they already have a degree of complexity because they already require a lot of the key pieces of the puzzle to be in place. Data sets, test suites, verifications, reporting, visualizations, all of that has to be in place. Even for the example that Matt showed now, which is a good example. Right. Actually, although the only problem with that, Matt, is that actually, it's a good example to the point where, that file should not be considered a JPEG anymore, right? Because it doesn't meet the foundation of a particular requirement. So that's quite cool. But actually, what we would argue is that every single CDR engine should fail that file.
Fail it right away? Isn't that kind of like the last step? Wouldn't the first one be to either replace or to move the part of it?
Say that again. Replace and remove what?
Well, wouldn't the so I mean, I guess if something's missing, yeah, you would want to fail it. But say there was something that was wrong about it, the wrong location or something, you would want to replace or move the things before files, right?
I mean, Jonathan can correct me if I'm wrong here, but simply replacing some of the stuff can be incredibly difficult, particularly when it's offset related. If you don't know what you're taking your offset from, then at that point it's impossible to locate anything else in the file.
Pretty much, yeah.
So with this, it's looking for a particular header and it knows to read things after a particular place in the header. So if it can't locate that header, it can't hop to the other offsets to find and move and remediate and replace or whatever else it needs to do with them.
Yeah,
I mean,
correct.
And that might be true, but in one sense, I mean, some of the things are going to be rendered not useful as it is, and others would be removed. So if a file is rendered, and I know you would have to understand, whether do you take off the stuff before, or do you take out the stuff, you'd have to figure in it. But I mean, at least if it rendered something, then you would have a an actual test showing that in fact it did do that specific thing, you could use that to test against whether or not, you know, the things were in the right place, because it would make them go in the right place. And it would be a messed up document, but it would be a document and it would be safe. And it would be according to the ISGs, it just wouldn't do anything. You know, there would be a way to test, I guess, is what I'm saying.
Well, yeah, this is Warren again. So one of the ways that, you know, we demonstrate the pre and post processing. So again, if these are malicious files that say group it into different CVEs, whatever, you want to demonstrate removal of several properties. So it doesn't have to be a new and something novel. You can always, you know, if you want to demonstrate several capabilities, then you can download whatever data set you need from VirusTotal. If something is known, okay, then you run it through the CDR process, and then can literally resubmit it on a post to demonstrate those elements, those specific elements have been removed. Of course, this is a sort of a shortcut, and there are shortcomings to this, but this is a way you can show it more en masse. And if your specific CDR solution has also the detection capabilities, and you can actually show it contained in your product pre and post, if that is possible. And again, this is another technique we use for demonstration of effectiveness. You know, and which is correct for this certain scenario, obviously not for other scenarios of like extremely mutated, novel, etc., or placement in extremely unique places in the files. But this is a demonstration method that can be used, that can be easily scaled and replicated.
This is something we've tried. Again, as I said earlier, one of the issues we found with that approach is that the majority of the files we were re-uploading were still failing through VirusTotal. When we pulled them down and conducted a manual investigation, we were actually disarming the threats. It's the whole thing, if we can prove this stuff manually, but that makes it incredibly difficult for us to automate, especially if we do something like invite the client to do it for us, and we've got to sit there for a while pulling the virus apart and going, as you can see, the hashes remain for the virus because the trigger mechanism is still there, but we've actually removed the underlying payload, or vice versa.
On the other hand, it is quite a neat demonstration of why signature-based detection isn't the be-all and end-all.
Oh, absolutely. It's proof of value, but it can be time-consuming if you've not prepped all that side of it.
True.
So I just want to give Ken if somebody can ask the question. So NA has posted into the chat. What's the benefit to automate taking the same file and placing malware in multiple places of the file and detecting where it breaks and how? So as Matthew demonstrated, the manual changing in many different locations, learning as Wallaby said, therefore changing the same location will cause an error. So I think it's got any comments?
So in a sense, I guess, are you saying making sure that it doesn't mess up the actual structure of the file, but putting it in different locations that wouldn't do that? Is that kind of what you're getting with changing the same location will cause an error?
But in a way, NA can answer that.
Oh, I get what you mean.
Yeah.
Well, I think in this case is like Oren was saying, you know, is actually putting malware in, or signatures of malware in files. You know, that is sort of showing that, you know, signature-based solutions are not very effective, right? In a way, it's almost triggering false positives on the other side. Part of me likes the fact to have a wide variety of fuzzing techniques, because there's always some things that you might pick. And some overruns and buffer overflows or some gaps that you might create, but I would say that, you know, the fuzzing and the automatic fuzzing of some of these things, it's again we're running before we even walking, right? I think at the moment, you know, if we can create data sets, and the data sets are, you know, some of them manually created or manually curated, and then, you know, we focus almost on how do we scale the execution of those tests? How do we scale the report creation? How do we tell the story of those tests? I think that's a good place to start, because at the moment we don't have that. And actually going back to, again, what Ora mentioned, think about the multiple dimensions that we want to present the test suites. And we're not talking about, 50 dimensions. We're talking about 3, 4, 5, 6, 7. We're not talking about 100,000 files. We're talking about, smaller subset of files, but they are files that go, on specific use cases that actually show the value of our industry, but also allow the benchmarking of almost the minimum, CDR capabilities that we want engines to have. Right. And actually, Matthew, the test you had is a good example, right? Like, we should create files that every single engine should fail, right? And the file you just created is a good example, right? Any engine that receives a JPEG or a PNG that doesn't have that thing on and survives on the other end, is not a CDR engine, right?
Yeah, that's why I picked that one for the easy example, because the ISG literally has validate and reject.
But the thing that
but there's, I think there was a comment earlier mentioned that surely the rejection of the file should be the last step, because there's an element of this where you can actually sort of correct that, especially if you're sort of inserting data at the start. If you can parse the file, for instance, in multiple parses, you can take multiple parses of a file. There's a good chance that you could correct a lot of this stuff.
That's kind of an interesting way of kind of what, and that's, I think, where you potentially get some of the differences between the different engines about what they'll fix, and what other engines might actually say, actually we're going to reject the file for it. And I think that's kind of what is one of the interesting sort of things there.
I've seen this example. I can't recall which sort of product was doing this, but I was kind of basically pitting it against ours. And the file that I was looking at was specifically a PDF file where there was basically a lump of data at the start, which just some random binary data at the start of a PDF file. But this particular product was able to kind of skip over that data, remove it, and reconstruct the file. Whereas because we didn't recognize that header, for instance, we failed it almost immediately. So there's the possibility where you can't just say that every sort of CDR product should reject this file. I mean, you can't create files where they should definitely reject it. I just mean that this specific example probably isn't one of them.
Well, we've actually, presumably these things can be configured to act in different ways. Mm-hmm. So, like Glassroll, you could configure it to either remediate things like that or to, sort of invalidate, mark as non-conformant.
But that's kind of where the INGs kind of give you that benchmark of actually what's the right thing to actually do from a security point of view.
But that's where I'd sort of argue a little bit, because although the ISG may say in that particular instance you should throw it out, if you can reconstruct the file that then is actually valid against the ISG, does that mean that we should be throwing that file out?
Well, no, as long as the end file that they receive on the other end is ISG conformant, they don't really care, right?
Precisely.
That's the point of this.
Yeah, precisely.
There's something where in time you could probably use a machine learning algorithm which could look at this and go, well, the first few bytes are wrong, but it looks like a PNG, so we can correct it.
Mm-hmm. Yeah, that's kind of, I mean, even if it doesn't actually render properly, it doesn't look good, it doesn't, it's still going to be a PNG, and it's still going to be according to the ISG, and even if it's crap, forget the language, even if it's not good, it's still going to be rendered.
Correct.
It's still going to be
obviously in this instance.
In some cases, these can be corruptions through sort of file transfers. I've actually seen a case where simply copying it to a specific USB has actually caused a corruption like that. And if you're able to remediate that, you then get a perfectly legitimate file that's actually valuable and useful.
Yeah, and I think the first step really is taking that step to start trying it, see how that works, see what you can do with it, right?
Mm-hmm.
Well, obviously the other side of this is making sure that they still match the manufacturer specifications as well as conforming to the ISGs. doesn't matter how things conform to the ISGs, if they don't conform to the original specifications, then they still need to be binned if they can't be made to do so, because they won't render at all anyway.
Yeah.
Well,
Yeah.
the ISGs are based on manufacturer specifications, so if
But they're not all encompassing. If you look at some of the things, like I checked the PDF one, and there was only about 49 different validations, as opposed to however many we've got in our engine.
Right.
I think that comes back to what we discussed in one of our earlier ISG sessions, where I think on one of the slides there was a level of risks, and there's I think there's 4 different levels that we discuss. One whether it's ISG compliant or not, and one whether it's spec compliant or not, and then the combination of them.
It's quite coming back to that discussion again. Is about when you find something that doesn't match the ISG, you follow exactly what it says, and it says if you find this, reject it, or actually because you've got enough information to know what that is and you know how to fix it, do you fix it?
I mean, it would be ideal if you could fix it. That would be the first thing you want to do.
Isn't that what we tried, Jonathan? You can back me up with this, but isn't that the whole premise of our core engine? We try to fix as much as we can.
Yeah, mostly we do.
Correct. Yes.
But then I guess you then end up with the catch question of, like, you know, if a particular customer, say, you know, a big United States government organisation, like, you know, has a spec of thou shalt validate according to the ISG, then arguably we should be able to do strict compliance to the ISG as one of our modes of operation, and, well, pain as it would be, not do those validations. But I guess we'll see where that situation.
Yes, it's a conversation I actually had with Steve last week about perhaps having a secondary suite of DVLs, so you could either validate as Glasswall or validate against ISG.
Yeah, and as I say, it's not something which has come up yet, but I can imagine some of the more pedantic sort of people in the "we could tell you, but then we'd have to kill you" business might sort of require specific, very specific set of.
On the other hand, I think the point of this ISG is for what they receive. I don't think they care so much about the original. As long as the regenerated confirms to the ISG, they don't care. So if we fix it internally so it comes out ISG conformant by doing it our way, I don't think they'll mind too much.
Yeah, I would say our way is more useful.
Well, this is for conformance on their end. If it comes out of our side conformant to them, I don't think they mind that we've changed it and fixed it.
Yeah,
I would agree with that.
And fundamentally, right, I think and this is where, look, you know, it's important not to also go into absolutes on this, right? The main thing here is to have a rational way to have these conversations, right? At the moment, we have no frameworks, no benchmarks, no standards that we are, you know, pinning ourselves against, right? And including, you know, the industry. So if the end result means that, you know, we choose to follow the ISG in, you know, 98% of the cases, or the 95% of the cases, or 90% of the cases, but we have a rational explanation for those other 10%, that's okay, right? You know, the point here is to have a very clear, you know, like, it's the so what, right? Every time we do something to a file, there has to be a reason why it's done, right? And it has to be linked, it has to be public, it has to be known, can't be black magic, has to be industry standard, right? And it's kind of simple, right? And, you know, and this actually gives us a lot of flexibility, right? It means that if new threads are discovered against a particular file format, against a particular structure, against something that we now recognize as problematic, it should be a patch, right? A patch that, in a way, the better, you know, or the more customized the rule set becomes, you know, the more you do it, right? So, you know, but the good news is the ISGs, I think, are already meaty enough to provide a great standard, right? And at the moment, I don't think nobody, in fact, it's impossible for anybody to be looking against the ISG unless they have a test case and an automated way of checking it, right? So unless somebody privately have developed that, those documents are uncheckable, right? Because they're too big. It's like, you know, who the hell is going to check that manually, right? It's like, you can't.
I mean, honestly, though, if you think about it, And this is kind of, at first I thought I kind of agreed with Matt, but at the same time, I think they would rather ensure the actual data in there is the data that came through, like the government organizations. I think they would rather actually ensure that that data is the same data that came through, even if it's broken, rather than to actually have it fixed and function, but have it be changed. Just with the whole,
Then you're negating the whole idea of removing the potential payloads and the making safe of the file.
I mean, I think if
Like
that's
you're
what,
saying only allow known safe, at which point you wouldn't be using CDR, you'd go to a conventional AV vendor.
I mean, if they can see what's happening, or if they can see what happened, then they'd probably be fine with it, knowing that. But if they didn't see what happened, then they would probably want to actually have something separate to ensure that it becomes something usable, rather than actually have it all packaged together and it comes out and they don't know what's been changed or what hasn't.
There are a couple of other kind of interesting sort of like paradigms here about some of the stuff. Certainly with some of the really high security type of implementations of or implementations like file transfer, where effectively the normal rules are you kind of try to do it, you run through multiple times, preferably with different types of engine, to get something that is actually safe out the other side. And I think it's the dimensions that Oren actually mentioned is the safeness versus usability. And one of the certainly one of our customers is 100% focused on the safety and will accept the loss of usability. But we know that there'll be other customers where that loss of usability, will be a deal breaker. It's not necessarily a one size fits all, and it needs to be specific to the particular context of a user group of what they really need. And you need to have a certain amount of flexibility for the engines.
And that's why we have comparable policies.
Yeah.
Then you run it through a certain way. You can run it through strict safety. You can run it through for strict safety and fixing, like actually have it be in autopsy. But actually,
about 10 minutes to go. Do you still have any more things to present? Just double checking.
The only thing we were kind of really gonna have a look at is these ways we can automate the collection and creation of data. And I think from the discussion, I think really it's kind of saying actually we just need to focus on actually let's create something, even if it's just manually, so we've got that minimal set that we've got to start with. And then I think that would be my that would be kind of my get for that. So that was about the only sort of thing to do is to say, like, what ways can we automate? That was the only sort of thing that we really wanted to discuss.
Well, for me, I think the path, and I want to review again that session because I haven't heard all of it, but I think the path to creating test suites is, I think, Elvin, when we spoke about, was the idea of using some of the object models that you already create from the files, and then using that to create the fuzz files. So I think that for me sounds like a really great approach, because you already have
even just using our validation rule to create the fuzz files, because we know the bounds they need to be in, so we can just fuzz stuff outside of them.
Yeah, and the object model of a file, right? So if you take a file that you open up, there's a mode where you actually have that object pre-validation, right? You already got all the components of the file already, in an object in memory.
Yeah, that gives you the map, and then the DVL gives you the rule set.
Yeah, correct.
Yep. So one of the approaches that I was thinking about is actually it pulls those two components into it. So you're using that DOM tree as well as the validation rules. So one potential option is to kind of go through the ISG and look at what rules or recommendations they've put in there that kind of map to our validation rules as well, which then means that if we can label those validation rules within our sort of DVL, data validation language, we can kind of put little markers in there to say let's corrupt it here or fuzz it in these areas, which means you've now got a programmatic way to auto generate that data, and it also kind of aligns to that ISG.
I have to say I'm feeling faintly nervous about the idea of using the same set of rules that we use to actually, effectively sort of generate our product to produce a test data where testing it kind of feels uncomfortably like we're testing it against itself.
That's why I was suggesting actually keeping it isolated so that it wasn't going to be on the same system. You don't want that to touch, but you do want to know where to make it stronger. You're pen testing your own system with itself, or with it like an adversarial network is basically what it is. So what you want to do is you want to have it isolated.
So Jonathan, we're doing exactly that. We're using the object models to create payloads to then, to test the system itself, right?
Exactly.
Well, except we're using the rules that we've already implemented to create those fuzzing rules.
Well, it's a framework, right? You always think about this as you start with a new file, right? You start with a new file format. You have nothing, right? This is almost like the TDD approach, right? The first time that you add, you take a use case. I want to protect against X. So guess what, right? If you find a way to read the file so you can find that X, you should also be able to create a file that has the X, in multiple ways, right? So,
oh yeah, I wasn't disagreeing with the approach. I was just
you also have to
bear in mind.
You have to bear in mind that if we go back to that ISG discussion, the first step that we sort of mentioned in creating that data was to actually switch off the validation, remediation, and sanitization of those objects. So effectively, you've just got a parser. And if you wanted to take it a step back, you have to bear in mind that our engine's built off an intermediate language, which behind it has its own tool set. So you could also use that tool set and that framework to generate that data if you don't want to necessarily rely on the engine directly. But this is effectively, you're using the skeleton of the file structure and markers in between it to kind of say corrupt these areas, not necessarily parsing, regenerating, rebuilding, manipulating. That's all been pulled out from this actual test, the data generation part of it.
Yeah, and I know that the rule sets came directly from the specification themselves, so that's not really a worry because we're not testing against our interpretation of it. We're testing against the specification itself.
Yep.
As long as we've interpreted it correctly in the first place.
And as long as we're not touching PDF.
Don't go there.
Well, look, this is also a great way to eventually get involved, the people that develop these file formats in the first place, right? I feel that the bigger elephant in the room in our industries is where are the file parser creators? Where are the file standards developers, right? They should be here. They must have their own test suites. In fact, they probably struggle to create test suites in the first place. So there's plenty of room for us to collaborate here. And eventually we should be, imagine if those DVLs that we have, if those initial specs were actually helped and maintained by the people that create them. So that next time, when they publish a new version, it already comes with this updated spec, right? Or else we always fighting against new versions of files and document change, etc., right?
That would be lovely. One has to assume that
we should make a list of people to bring.
Sorry, Jonathan, you're saying?
Yeah, I just think one has to assume that, for instance, Adobe have a pretty good test suite for validating new releases of Acrobat and/or Reader. And if we had access to that, then that would make life much easier.
So when the Adobe guys are listening to this recording, for the record, we absolutely would like to work with you guys directly.
Oh, please.
Well, to me, even, I mean, PDF is one of those because it's quite complex, but even as just for some of the things that's hurt us, it would be, even like with Microsoft, when they've added new features, and one of the issues that we've had recently where it looks like they've actually changed how the file works, but actually not updated the specifications. It's kind of just even to get involved in that conversation, so we're not surprised by it and having to react to it.
Yeah, and again, for the Microsoft crowd watching this recording later, we absolutely want to work with you, and we want to collaborate and contribute back, right?
Interestingly enough, there was one time back in my short time history in Glasswall, I think Sam did have a bit of interaction with Adobe, and we did have to write something to them explaining about JPX. I'll probably be able to dig that out in my Outlook box at some point.
Yeah. Right.
We know some of these people are quite receptive because we had those issues with file scanners as well, and they updated the scanners to work properly.
Yeah.
I remember that one. That was fun.
Greg, any other wrap up? Or what's the next steps for this? I definitely feel that we should think about when we're going to meet again, and when we're going to do another set of these, and then using these sessions to bring a more of a wider kind of sort of community to it.
I think we should. I've kind of been making some notes, I think, of some of the really key and interesting points for that. So what I'm trying to do is kind of update this slide deck with some of those points that come out of some of the discussions. As much as I can read my own writing 10 minutes after I've done it, and then we can kind of publish that. But I think it definitely as part of this, as part of the discussions, definitely with some of our other, other vendors, who've kind of made, I think, some really good contributions to this.
I think it would be a good idea to put together, and I may have said this, but I got booted off, so I don't see anything that was up here. But it'd be a good idea to bring together, or at least make a list of people to bring together for.
Yes, unfortunately, NA has dropped off of here because he had a lot of good input, and it would be nice to have him on that list as well.
Yeah, but I think, look, don't underestimate. Like, we now, the power of these sessions is that we now start the conversation. The videos are available. Like, for example, like, the guys that were here, they can go back. Oren can now go back and see, the sessions. And we just need to think about what was going to happen next. And also, for you guys to see that, there's a lot of power in having these sessions in a public forum.
Yeah, I mean, for me personally, it's the first time we've really been talked to people from other people in the industry. And really kind of, I thought, got quite a lot of value out of it. Yeah.
Likewise.
And that's how we collaborate, right? That's how industry forums are created, right? So, and I think we're now in a very nice privileged position where we can drive this. So let's take advantage of it, right? Like I said before, right? From as long as we're not sharing customer data or the actual source code of the product, right? Or employee data, it's okay, right? Because we need to grow the industry, and this is how we collaborate and find a better way to do it. Cool.
I mean, perhaps one of the things we ought to try and just do is just like take one of the file types, one of the sort of simpler ones, and just say, right, let's just create a set of data for it.
Yep.
And then we got, because now I think for the various discussions with whoever that is, we can just say to, we can say to George, say to the two Orens, he says, okay, here's, contribute if you want to contribute to it. If not, try it, run your engine through it, see what you get. This is what we expect to happen, and we can start getting that, building that set and kind of finding out what issues we actually find as a group of vendors of having a good set of data that we can all use.
Well, we don't even need to build that set. We've already got simple versions of that kicking around. Look at, this won't be much for the rest of you on the call, but the content management sets, they're all built in-house. They can be published. That will give you a direct high-level bunch of things that you can validate against, and they're all stuff that's referenced in the ISGs as well, like the treatment of macros and review comments and embedded data.
actually, that's a really good example, actually, because I've already given those out to people.
Yeah, and those are all built in house. We haven't got to throw out copyright or anything. Those are directly shareable. We could kick off with just that.
Yeah.
Goes back to
really
what I
like the
believe.
idea. Jonathan had a really good idea that we can run these sessions like this. So maybe what we can do is we can use the Open Security Summit as the kind of umbrella for the collaboration, but then do almost sessions that are happening at the same time as other conferences, just because, you know, there's a bit of a focus of, you know, of talent around those conferences, right? Or even try to do it within their environment. But I think it's hard to do it in their environments. Yes, if you go on site, so I was just thinking virtually, yes. If you go on site, yeah, we can do a Black Hat session there, right? Where we get together for the people that go to Black Hat. Yeah.
Or even run an unofficial one at the Starbucks across the road.
I mean, it is a shame on some of these discussions that we haven't necessarily had more representation from other people that are at the summit, because I think there's, I think there's some really good people who've been in some of those other sessions to kind of just to get that.
Let's continue, right? There's nothing stopping for us from having another CDR day in a month from now, right? Or a CDR afternoon, right? In a couple of months, whatever, right? And then that allows us to build up invitation, because now we got a nice follow-up, right? So if you think about it, the next set of sessions should be to show and continue from where we are now, right?
Yeah.
Cool. All right, Greg, give me a debrief of this session.
Well, this is the bit I hate. So,
but you're so good at it. That's why we keep asking you to do them.
Yeah. Okay. So in this session on creating a set of common data for CDR testing and QA, we looked at some of the issues around data for not only for test teams but also for vendors and customers. A quite interesting discussion on what type of data we need to collect, how we can categorize it, what some of the issues around that. We did a very small demonstration of some of the tools, very basic tools that we use for actually editing some of those files, and there was again further discussion on actually are there better ways to kind of generate some of our data through fuzzing or other things like machine learning. And finally, we kind of said, yeah, we want to continue doing something similar to this, get a lot more cross-vendor participation. And that's the summary of this session.
Brilliant. Stop recording.